All right, guys, welcome to another video dealing with volumes. So we're going to take a look at volumes of pyramids. Now, as you might be able to hear, I'm not sure if it's being picked up in the audio or not, but I think somebody's practicing drumline inside the building. So just do your best here to enjoy the music while learning some math. We're going to take a look at volumes of pyramids. And here's your formula. So the volume of a pyramid is equal to 1/3 times base times height. And again, remember, this capital B is the area of the base, okay? So remember, whenever we see this capital B, that means not just, sometimes people are like, oh, well, that's the base, but they don't know what that means, okay? So we want area, that's a terrible spell, or terrible handwriting, but area of the base. Okay, so area of the base, that's the capital B. And that's the same as when we dealt with prisms and cylinders. Now, if this looks a little bit familiar, that's a good thing, okay? Remember the area or the volume of a prism. The volume of a prism is base times height, the area of the base times the height. So notice the only thing we added here was the 1/3. Now, this is a little tricky to see, but you can actually fit 3 pyramids into a prism. Okay, so let me kind of show you an image here. So the yellow, blue, and green are all right pyramids. So they've got, instead of maybe having the point of the pyramid right at the top, it's actually like lined up with one of the corners. And so you can see how these 3 pyramids all kind of fit together. And this is Brown. The University Brown has this and other stuff here at this website if you want to check it out. But I thought this image was really helpful to kind of see the 3 different pyramids that can make up a cube in that case. Okay, so that's not really a formal proof, but it helps us to see why we're doing base times height times 1/3. Okay, because we can fit 3 of that pyramid into a cube. All right, so let's go ahead and let's solve for some volumes here. So let's deal with the volume on this problem. So I want 1/3 times the area of the base times the height, right? So notice the area of my base here. It is a square, so that's going to be 4 times 4, okay? So 1/3 times 4 times 4. And the height, now remember, height means it's going straight up in the air. There's a difference between something called height and slant height. Height goes straight up in the air, just like that 6. So my height here would be 6. Slant height is this light blue line here. Notice how it goes, like, slides down the side. So the best way I can think of it, it's a terrible way, but it's the best way I can think of it is if you were like standing on the top of one of the great pyramids in Egypt, and you took a drill and you just drilled straight down, that would be the height of the pyramid. But if you got like a giant sled or something, you tried to like sled down the sides, which in theory works well, but if you actually, I think it's just giant blocks, I don't think it would be particularly successful at all. But say you were to try to kind of slide down the side, that would be like your slant height as you kind of go down the pyramid, okay? So anyways, we're interested in the height, the straight up and down for finding volume. So 1/3 times 6 is 2, 4 times 4 is 16, so I end up with 32 here. All right, let's try another one. Now notice in this case, the 6 is only half the distance here. So the whole distance, and again, we're going to assume that this is a square base unless told otherwise, this whole distance will be 12. And so that means this distance here would be 12. So once again, I'm just going to set it up. 1/3 times 12 times 12 times 9. Okay, so that's 144 times 3, which is 432. All right. That seems pretty straightforward, right? Well, let's look at one problem where this gets a little bit more challenging. What if I have a case where I have the slant height but not the real height? And again, we're going to assume that this is a square pyramid, a regular square pyramid here, okay, with 10s all around. All right, so how could I go about solving for the height if I have the slant height? Well, let me show you. So we can actually think about this right in here. This triangle right here, the height with half of the length and the slant height as being a right triangle, okay? Where this is H, this is 13, kind of taking a section out. Okay, we're pulling that triangle out. And then how far is this distance from the center of the pyramid out to the edge? Well, if this whole thing is 10, this piece right here should be 5. Okay, and I should know how to solve for the missing side of a right triangle. If I've got two sides and I'm missing the third side, I'm going to use Pythagorean theorem. So 5 squared plus h squared is equal to 13 squared. All right, and I can solve this out. H squared is equal to 13 squared minus 5 squared, which is 144. Take the square root of both sides. I get h is equal to 12. All right, so my height here would be 12. All right, well, that just solved for my height. I still need to find the volume, right? So the volume would be 10 times 10, okay? 1/3 times the base times the height. Well, the base is 10 times 10, which is 100, times the height, not the slant height, times 1/3, and this is going to come out to 400 as a final answer. So just be on the lookout if you run into some problems with slant height. There are ways to solve for the regular height given the slant height. But largely, a couple key takeaways. The formula is 1/3 base times height. It comes from, it's kind of derived from your volume of a prism, which is base times height. And you want to make sure that your base is the area. You could have, again, different size bases. You could have triangle bases. You're going to have to solve for the area of a triangle. You can have a rectangle, or sometimes people throw in hexagons or things like that. So find the area of the base times 1/3 times the height, and you'll be good to go to solve for volumes of pyramids.